All right, well, let's get this started because we've got a lot of stuff to cover in today's webinar. Our webinar is on not that, Civil 3D pipe networks. And I'm Carl with ATG USA. I'm a senior civil technical specialist. And today we're going to be going over our training objectives are going to be our pipe network creation tools. We're going to show you how to create those from scratch. We're going to show you how to create pipe networks from objects, i.e. feature lines or polylines, and how you can leverage that to speed up your design. We're going to go over pipe rules and how we can utilize those and times that usually under your initial layout with using pipe rules, then later on using those to get it to do things that you want it to do. Layer settings, where all these fantastic Civil 3D objects go and how we can leverage that. We'll be going over some additional add-ons for Civil 3D, utilizing the CTC tools for speed of production and pipe design, and also a little bit in the new Project Explorer. You don't have that, how we can utilize that. We're gonna Civil 3D 2023 now allows you to analyze your gravity networks in the software, so you don't have to export it out. If you're also in here and you wanted to learn how to export that out, we're going to be using that down there, and how to customize your part mapper to get Civil 3D's storm analysis and storm and sewer to get the proper parts to run those analysis in there for your drainage reports. We're going to do a little bit with part catalog modifications and how we can add and how that works with the parts list, and being able to create custom parts lists, and a little bit on some custom labels. All right, so let's lay some pipe. We're going to open up Civil 3D 2023 is what I'm using here, and I have just a kind of a nice little site plan, somewhat graded out. There's obviously some tweaks that need to be made on there. I don't think our friends in the ADA community would be very happy climbing up into that, but we don't really necessarily. We'll have somebody else work on that grading while I'm doing my storm drainage. So the first thing we're going to do is we're going to create a pipe network using the pipe network creation tools. And this is a gravity system. Gravity pipe networks are usually for storm, sewer. I've also used them to do electrical duct banks. Pressure networks is going to be covered in a later webinar, so make sure that you sign up for that one. It's going to be a doozy on fun of pressure networks for force mains and water mains. So let's go ahead and just start in here. I like to actually demonstrate the tools. So we're going to call this Storm A for Storm System A. Here's all those part lists. And later on, we're going to go in and show you how to create and modify these for your particular company or particular state standard. And then layers. Here, by default, these are kind of set to 0. I'm going to show you how this can automatically get filled out and some best practices that we can use to where we don't have to fill this out every time. Right now, you would have to go through, and I don't even believe I have a storm layer in this drawing because I was naughty and didn't use the proper template when I began work this morning. And so then my CAD manager is going to come and yell at me later. They go ahead and create actually 3 layers. Storm using our company national CAD standards. See storm, and I see a lot of people using C-storm pipe profile and C-storm structure profiles and so forth. I've never had an opportunity where I get to cut both of those off at the same time, but if you do, then we'd want to go ahead and add those and separate those out. The only thing that's kind of with Civil 3D is it still keeps everything within gravity networks are all the same. So you don't have the option to choose between sewer and the difference between sewer and storm pipes, which would be really nice. However, what I tend to do is I'll set up a template and break out my sewer and storm into two different templates, and then go ahead and preset these to sewer and storm. The only time where it really comes in to get you later in is when you go to create your sheets, and then you kind of do still have to select which ones you want to do there for those. So storm pipe and see storm structures. All right, so this is how you can do it, those for each one of those. That's kind of slow, and I don't really like doing that. So we're going to go in and we're going to go to our settings here for this drawing. We're going to go to edit draw it settings. We're going to go to our object layers, and here's where we can go through and we can set these where we don't have to fill that type of stuff out anymore, because like I said, I don't really like to work that much. And so if I can speed up my path, that's going to save me some time, and I really like doing that instead. All right, yeah. Guess it didn't save those after all. Let's see, storm. Right. Pipe labeling. I'm going to label as C. Oops. C storm. Typically, this is going to be handled already for most users in your network. So you don't have to go through and set these, hopefully. But if you're a CAD manager and you're trying to set up a good template for your company, here's where you can go ahead and then set these up in your template. Make sure that your users use those. So just going to change that one to red as well. All right. Okay. Let's just stable out. See storm. All right. So once that's taken care of, now when we go back and we go to create our pipe network, those layers should have already been populated. Everyone can laugh now. All right. So utilizing our part list here, we've got some predefined parts. I believe this is from Florida Department of Transportation. And I'm going to use just some standard catch inlets in this parking lot. I tend to like to kind of average out what most of my pipe runs are going to be, so I don't have to go back and swap a lot of parts. Then over here, we have our create pipes and structures. We have three options: pipes and structures, pipes only, and structures only. This button right here is to change the flow direction. It's a good rule of practice to start from upstream and go downstream. And so I'm going to start over here, and I'm just going to drop in an inlet. I'm going to drop in an inlet there. But continue just going downstream on this. Let's put another little inlet there. I'm going to send this one off of my surface just to show you a little trick on that one later on. Then go into our detention pond. So in here, I think we're going to change this to a junction box or a manhole. Let's just go down here and select one of these. Now I have a storm manhole here and storm manhole here. Choose one of these. I'm going to keep that inlet right there. With these come in from the insertion points, and you have these little tabs that you're able to rotate the structures to match up to some line work. That works for all of your gravity part networks. Scroll down here. change that one to a manhole. And then down here we have, need this to be a head wall structure. So let's go in here. Actually, I'm just going to change it to a flared inlet. And I think my final pipe size is 30. So these actually get rotated 90 degrees if I'm not mistaken. Using the gravity system, the structures, when you go to move those will move the pipe and change the slope for them. Using this method, you can go through and then go through. There's two ways that we're going to change these. I want this elevation to be at 20. And then if you know what the slope is, you can, or what your next invert elevation upstream is going to be, you can go ahead and set that here. Right now, that's not going to meet my minimum design standards for this location. So 20. That's pretty close. Yeah. So the other way that we can change the invert and elevation on this one is through our pipe properties. And so here we have our invert elevation, start invert elevation. And so we set this one at 20. I'd like to actually run this as exactly 0.5%. So if we do that and then hit apply, it's going to do that mathematical calculation for us and show us that that invert upstream is going to be 2153. Hit OK. And we can go into this pipe and we can go, all right, yeah, that's going to be 2153 as well. We kind of go back and forth doing that to design our pipe network. I'm for a long time in LAN desktop, if you're familiar, if you're old enough to actually use that, you had a nice function to be able to select this one and this one and then do that transition. Well, I'm going to show you a couple of ways that using some new tools that we get that functionality back and save our time on that one. All right, so that's how you go through and utilize those parts. And for most users and your company, you can go through, select those parts, and begin designing. You can go through and swap parts. If for some instance that we wanted to, what we could do is we could go through and let's say, for instance, the design changed like it typically does. And we're going to add a small detention pond over here. We can go through and split this network into another network. And I'm going to split it and I'm going to create a new pipe network. We're going to call this Storm B because it's going into now my pond B. And same thing, setting our layers, surfaces, my label style. Then hit OK. And then see now up here, I've got this is Storm B and this is Storm A. Well, should have been Storm A. Let's go back and change that. Networks, network properties. Go back in here and go Storm A. I've noticed a lot of people go ahead and pre-populate these fields with the storm system there. And so what you can do is just go through and then edit that network and then start your design. If you go ahead and pre-populate all of that and have it ready for your users, that's a big handy thing. All right, so now on this storm system, I really don't even need any of these because I don't have everything's draining down to this one inlet down here at the bottom. But I would like to go ahead and do an outfall on this one. And I'm going to edit my pipe network and just going to select a 24-inch. And let's do a flared in section, 24 inches. All right, so now, oh, I'm going to have a little problem. I'm going to need to go back and toss this one. Remember, because we want to go from upstream to downstream on our design. So, oh, I know why that didn't work. Let's try that again. Because I was in Storm A. Why didn't somebody tell me that? All right, storm V and flared in section 24. Connect that up. And let's get rid of this guy. Make sure that he's connected. Why I keep switching to storm A. Oh, that's tweaky. All right, well, we'll just do this. We'll go to select a network. Go to select storm. Go back and review the footage and see what was going on there. All right. So now we've got two networks and through there. And that's one way that we can go through and design our pipe network. It's kind of a slow way. I actually like to do it a little bit differently. I like to go through, just do this both out. I'm going to take a handy dandy little polyline here, and I'm just going to snap it to where I think I want my inlets to be. There. All right, now we could go through and we could create a pipe network from that object, and it would still give us the 0 inverts on our pipe. An easier way that I found is to go ahead and change that into a feature line. And make sure this is on a separate site, because if it's on the same site, those are going to interact with your grading feature lines, and it's not going to like it very much. Hit OK. And we can just call this storm a reason to name your feature lines. And I'm just going to go through and we'll just change this to the marker. I'm going to go through and I'm going to assign elevations. And I'm going to choose my finished grade on this one. I'm going to have a relative elevation, meaning that this feature line is going to be relative to that surface. And I want it to go ahead and drop down 4 feet for me. That way I've got 4 feet of cover. So now I've got my feature line here. This is my outfall. So I actually need to change this feature line now to where the bottom of my pond is. I'm just going to set it at 20. And then I can go through and almost like design my pipe network at once. Around 0.5% up to this pipe run. And then I'm going to look at this and I go, well, I've got a 1% on this one. And let's do 1.3 on that one. And I'm going to go down at 1% on this one. And 1% on this one. And 0.5% on that. Okay, now when I go through and I run my create my pipe network from object, it's going to ask me which flow direction I want. Remember, upstream to downstream. Okay, and enter. And so now I can go through and name it just like I did creating it to begin with, and it allows me to pick my structures. I always like to try to pick the run that has the most amount of structure. So if I have a whole bunch of grade inlets, I put those in. If I've got a whole bunch of curb inlets, I try to put those in first, and then I can go back and swap parts. But then it's going to ask me if I want to use a vertex for elevations, and I'd like to set that as my invert. And so now when it creates my pipes, you can see here, it's already got the elevation set the same as that feature line and the slopes. So I don't really have, if I wanted to, unless there's design changes, I wouldn't have to go back and, deal with the pipe properties or manually putting out information there. And I just think the slope editor, the feature line, quick slope editor is pretty easy to put that in. I'm going to go ahead and use some of the analysis tools and verify that my inlets are in the right location. And see where this kind of flow to. It looks like I need to move that one over. That one's pretty close, but I could probably move it over as well. And then almost on that one as well. It's like horseshoes. I got pretty close, but I didn't win. So we can go in here and then rotate that one, put that one right there. Move it to this endpoint here. You can also use those to create your flow path for your catchment areas. And so intersection. All right, got it done with those. So select similar, delete. So now that we have a decent pipe network there, let's the two ways that you can create pipe networks. One of them's a little faster than the other, I think. We're going to go through and use some other modifications and tools to change these pipes. And swap that one. And one of our partners, CTC, they make some really handy tools to go through and set up. And one of them is part swapper. So we can fire that up here, right? And you can just do the entire network or by selecting those parts. And I'm just going to select this one and this one and this one. And then now what part do I want to, I can even switch to a different parts list if I wanted to, but I want to replace the structures on these with those manholes. So I can go down and then where are my manholes? There they are. This alphabetizes them, so that's kind of handy. And so we can go through. Now all those parts are swapped at once instead of doing them individually. If we want, we can also go through and use the pipe planner tool. And we can go through and select our network here, store. And then here we see that we have all of this functionality that we can go through and change those parts and pipe sizes. And just go through there and go, all right, all those manholes, just move over here. And that gives us those IDs. And we can change those around. And allows for that to export that out into Microsoft Excel. If you're still doing your design through Excel, it's a real big saver there. So you can kind of import back and forth. The pipe designer with the CTC tools is really fascinating. Like I was saying with LAN desktop, we had the functionality to raise and lower pipes and structures, and that was kind of taken away from us. And the pipe designer allows us to get that functionality back. So I've had some changes where I've had to go through and lower my entire pipe networks by a foot or two, or raise them up on, really large sites. And instead of having to go through and individually doing each one of those pipe runs, I just ran it all at once. And it, pretty much allowed me to do that in just a fraction of the time. The pipe designer here, you can select each individual structure, or you can go through and just do it's all at once. Save us some time. Select someone. Pipe designer. And just select first point. That one, that one, that one, that one, that one, that one. This one. Just do the whole network. Oh, I changed that one to a manhole. Here's a nice little user interface here that's going to tell you that you can go through any of these ones that aren't grayed out. You can modify that information. So instead of pipe 432, we can go, pipe, or let's call this like this. Oops, yes, I know. A1 to A. Let's call this structure. Name all our structures here at the same time. A1. 3. And I actually did that backwards, but that's fine. A4 and A5. Before we'd have to go through and do this either in the properties or take care of that. Okay, and then we can go through and we can apply some of those rules that we have. We can interpolate slope between certain pipe runs, and we can set those minimum covers based off that too. Or we can go through and we can just go in and we can match crowns, which is convenient for those. We can go through and we can edit those elevations manually if we wanted to, and say we wanted to change this now to 21, not 212. That's a lot. So 21, and then it'll go through and show us what slopes we're at here, and then we can just apply that functionality. And now it's gone through and it's updated our pipe network continuously. Then once that's done, we're gonna hit OK. And then so now it's at 21 and 2151. And so definitely check out the CTC tools for that. If you have access to the Project Explorer, it also will do that as well. That's a new functionality, I believe, in 21 and 22, 23. If you have the Civil Project Suite, you can go in and then here where you'd select your pipe networks. This is our storm run. We have edit pipe runs A through A6, which is our entire run system, and it kind of previews it for us. Now we can go in and end of our pipe elevation run, I'm going to change that to 20. And I'm going to hold that pipe elevation run, and I want a 0.5% slope through the entire thing. And so that's taken care of. If I wanted to go through and then make sure that all of these are set to my finished grade, a lot of times we don't. Our pipe networks to our reference surface. Set that to as well. And we can go through and then also check and make sure that we have maintained minimum cover on through there. This one actually probably needs to be set to existing. No, we're not meeting minimum cover because that outfalls to our pump. Okay, so then once that's taken care of, you can see that there's a downside to this, and it's that these structures don't update to the sumps. And so what you end up having to do is go through and apply that pipe rule to it. Just apply rules. Apply rules. And one of the rules that I have set up in here for this is to match sump to my invert elevation. So if we go down here to our structure rule set, and then let's just do storm, for instance, go in here and we can look at those. And right here for set sump depth, set it to 0. And then we can add additional rules to have it check and make sure that the pipe is not so pipe's not bigger than the structure. And all of those can be applied to your standard part list. And so now once that's all complete, let's actually go into that part list and I can show you what we're doing here. Chat. Is that because the structures were modified by CIM Project Suite? Because the inverts did not go to the structure there, Chris, or That actually, no, that's actually Project Explorer that does that. The CIM project suite actually links those back together. So that is a big pro on that one. Other ways that I've seen done this before is where you go through and you select all the structures and just kind of move them and move them back, and then it automatically updates those. That inverts to the sumps. You can do that, or you can apply those rules again and it will update to the sumps. And so that's the ways that you can handle that. Thanks for the question, Chris. Excuse me. All right. So with the pipe network and the part list, this is where we start getting into a little upper level stuff. Here we have our part list, and we're going to go to edit. Within this part list, we have some pipes and structures. So my pipe section here, I've got concrete pipe, PVC pipe, and electrical pipe. What we do is we want to add a part family, or say yours doesn't have these. I'm going to show you here in a little bit how this builds off of the part builder. But I'm going to add a part family, and here I've got a variety of different types of pipes that's been built in the part builder. And to kind of keep these separated up, let's go ahead and just let's create some corrugated metal pipe. All right, so once you add that part family, you need to add some parts to it. And so then you go to right click and hit add part size. And here we have an inner diameter of 12, and we have the option from 12 to 144. I'm just going to add a few of these. I'm not going to add all of them. And then the material that we can use on this one. Right now, this just says reinforced concrete, corrugated, and undefined material. I actually need corrugated CMP for my material, because my label is going to call out corrugated metal pipe. So what we can do is cancel out of here and go to our pipes, go to our part builder. We're going to go to that corrugated metal pipe. If you don't have this one, what you can do is you can just open up an RCP one, and I'm going to show you how to change the variables on those to meet the corrugated metal pipe. Corrugated metal pipe. Hit close that. And this is the part builder. And part builder works mainly on references to dynamics and formulas, and not necessarily Civil 3D or AutoCAD line work. In this particular case, we did open up the circular CMP pipe part. If you wanted to create one, let's say you were doing ductile iron, then you can just save this part family as ductile iron, and then it would save into the location. By default, all of this is going to be stored on your C drive. Under C drive, program data, Autodesk, what version you're using, that good old ENU file, and then your pipes catalog. What I found on a best practices is to go ahead and copy pretty much all of these folders and then put them on your network drive. And in this case, my network drive is going to be a USB drive, but I have all my Civil 3D support stuff in here, so I can make these modifications, and then we can path the user to here. So as you make updates as a CAD manager, we can go through and then set up those paths under set pipe network catalog here to that location. And so as those updates are made in that one location, then they will go out throughout the rest of the company. The downside to that is if somebody does not have this path and opens up a drawing that you're in and then starts working on that network, they're not going to have those parts. So keep that in mind. If you're having some issues, that would be why. Here on our corrugated metal pipe, need to add some parameters, and I would like to add a material parameter. And there we go, material. And then the parameters configuration is going to tell you what each one of these little attribute names do and how it's calculated. This material is listed as a constant, and I actually kind of want that as a list or to a table. And so now when I go back and I change that over to values, put that up, we've got this undefined material. I can go up here, I can select, oops, whoa, okay. Having a good time here today. Material, fat fingers. Going to values. One. We can just change this to corrugated metal pipe. Let's do that. And it's uppercase. It's going to update all the way through there. And then hit OK. And then so now we have that material added to that pipe. Other functionality on here. If we go back and we have, see, we've got a wall thickness. And then this is based off of a table as well. So corrugated metal pipe is probably going to be a little thinner than the wall thickness than that you would have with like reinforced concrete. You can go through and you can modify these into the sizes that you need for your wall thickness. So if it's 12-inch inner diameter, then your outer diameter is going to add this wall thickness to it. And then that's what's going to be shown. You also have the part size name, and we can go through and you can actually edit this to here if you wanted to have it call out. If you wanted to have it call out the part name instead of you know, the width and stuff in your label, you can go through and modify those here. I'm just gonna go ahead and save this one now and close out. And a lot of you are going, why didn't you validate that part? I did check and make sure it was green. Okay. All right, so now let's go back. We can reach this in two ways. We can go through our prospector, or we can go up here to our parts list and edit it this way as well. We're gonna go down and we're gonna make a storm. I didn't click that right, did I? Did not. Storm. Okay, so now we're back here, and I'm going to add my part family of my corrugated metal pipe and add a part size and my material. It's already set for me as CMP because we didn't add additional ones here, so you can't select anymore. So I'm just going to add the 12-inch here, and let's just add a 18 while we're at it. All right, while we're in here, we can go ahead and have this do a lot more work for us. So we can go ahead and we can set up styles for each one of these pipes. A practice a long time ago was to have a style for each width of pipe. So you'd have a 12-inch style, 18-inch style, and so forth. That got that was making a lot of styles and a lot of work. But if you set up your part sizes properly, you can just use the part dimensions and it will scale that off. So you don't have to go through and then do offsets and diameters for each style. You can have just one style to handle that. And same thing on your profile, use those part dimensions. And in this case, I'm going to have this, change the style to my storm pipe layer that I liked instead of the utility layer that I had. And then outside pipe walls, put that on the same. And storm pipe. Right. Remember that there's multiple tabs in here to change that and how they look between plan and profile view. And this one we can go through and we can change this one back to over to see storm right there. And so that kind of matches them up depending on what your company standards are or how you're trying to set this up. You know, you put these on different layers and so forth. I'm just going to do that. And I'm just going to change that one. Have it add to pipe rules. We can have, and this also works for structures, but if your pipe, you know, let's say you're doing a sewer parts list as well. Well, your minimum sewer slope for an 8-inch is potentially, you know, 0.38 minimum. I think usually we run 0.5%. If you go up to 10 and 12s, you can get a little bit shallower. You can go ahead and apply those rule sets there for minimum and max slopes, where they will not, they won't allow you to exceed those or go below those. And then over here with pay items, we can add this where it will calculate the links and types, sizes for us. So I'm just going to go. I've got an Alabama one here that works fine, and I know everybody is. It's in Louisiana would probably just trying to kill me right now. So go here. We're gonna remember how I told you, like, you know, on our network, we have everything located at. And so we're going to go into here and we're going to go to our Civil 3D files, pay item data, and US, Alabama, and which one is that one? No, it's that one. All right. And once that's there, we can go through and we can then start adding pay item information to our system here. Corrugated metal pipe. Let's see if I've got that. I don't have a pay item for that. Pipe. Let's do a search, removing pipe. Let's turn it on. Go to 600. Culverts and drains. We can search by sections. And select which one that you want to add. You can add multiple ones here too to your pay items to get it to calculate out. One of the newer functions over with the structures is structure type, and we can go through and we can change this where when we export it out, that it works with the functionality and storm and sewer analysis. And so we can do that in our parts list. We can go through and give it a great calling from that part. Instead of having to go through storm and sewer analysis, we can, and if it's already calculating the throat diameter or the throat width of your structure, we can have that put in to the functionality in the part list as well for each one of those. So it just doesn't save. That's going to be a great inlet. And apply. All right, so and that was a brief rundown on the part list, but keep in mind that, like, so this is based, your pipe that you draw is going to be based off of your parts list, and your parts list is going to be based off of your parts that's created in your part builder. So if you make need an update for your part builder, you need to update your parts list, and then you need to update the actual pipe network itself. Sometimes when you make all those changes, Civil 3D will sometimes get confused, and you'll need to kind of almost reset your part list, like right there. And so what I'll do is I'll just select another part list and then switch back to the part list that was previously there, and then the functionality will be available. Looks like we're running a little late and behind on everything that I wanted to get out. All right, so let's go ahead and I'm going to swap that one thing here done from a manhole to a head wall. So part. And then we're going to talk about migration tools. Not that where it in section. Just do it 30. Oh, I know what I wanted to do. All right. So after we got our network drawn, now one of the functionality in Civil 3D is allow you to analyze that network in-house. In order to do that, you're going to need to go ahead and associate some drainage areas to your inlets. And this is overly sloppy, but we'll let it slide for today's presentation. Let's just do all of this as well. So if you use the Analyze tab and go to catchments, I'm just going to do these from object. And it asks for your flow path, which is going to be your time of concentration. Most of your post development is going to end up being about a minimum time anyway. If not, you can go ahead and add that. I like to name my catchments the same as I name my structures. So, and in this, I'm going to go ahead and create a quick label to call some information out for me. Change that to acreage. And let's type in AC. And let's go ahead and add in my time as well, or my runoff coefficient. I'd like that. And so C equals, we're going to use Manning's. I don't feel like dealing with SCS today. All right. And so it's all concrete. Under our flow path here, we have the option for TR55 or user defined. All right, so this one you can clearly see is in hours, but we calculate time concentration in minutes. So what I'm just going to do this one and finish it off. However, to fix that, we can go through and then change our drawing settings here. And we can go to ambient settings and then time, and change that time from hours to minutes. And I'm just going to go and select that to 2. If for some reason another one of your functionality was using hours, you can just go down to catchments and then change that feature setting here, and then run it, and then keep your other ambient setting to hours. Solve that problem. All right, so now we're just going to blow through these real quick, hit escape. And what I'm doing is I'm attaching this structure to that catchment. Flow path. Now I'm in minutes. Well, 10 minutes on that one, and let's just do 10 minutes on this one as well. Escape. Yeah. Catchment. Object. It's not closed. All right, so let's close it. Now, catchment, grid, object. This one, 9, flow path, 10. All right, so now that I've got my catchments created and attached to the structures, if I modify my catchments, my areas are going to update as well. Now I'm going to go through and I'm going to select my pipe network and analyze the gravity network. And you're going to want to load an IDF curve, and I'm just all over the place, anywhere, and select the storm that you want to design for. You can check the intensity table if you wanted to modify these, save and return, and leave mine where they are. And then it's asking what is my outfall. In this particular case, it's the A6 one. And if I need to apply a tailwater condition, if we're going into a wet pond, you'll need to give the surface water elevation here. You can manually type that in. Or in my particular case, I'm going to run this as normal. And then right here, it says some network detail information should be reviewed. So right now, all of those structures, it doesn't know what structure I'm using. So I'm going to go through and I'm going to use just a great inlet on those. Let me actually, great inlet is A1 and A4. All right, so I've got network details. A is going to be a great inlet. That's going to be a great inlet. And A4 is a great inlet. This is actually a manhole. This is going to be a manhole. And that's going to be a manhole. All right. Here, this is flagging you because you don't have any water flowing into the manhole. And so in which case it doesn't also have a runoff coefficient or time of concentration. And that's fine in this particular case because they're manholes and we don't need any of that information. Back, and then now I'm going to select to resize repipes, compute my energy and hydraulic grade lines. I'm going to leave my, and so right now the system, it's telling me that I can actually downsize my pipes to 15-inch diameters. And then that first one, I can actually change it to a 12. And then when you roll over it, it will tell you like, hey, before this was originally a 12 and we optimized it to a 15. And that one's a 15. Originally it was a 12 and we optimized it to a 15 on that run. And what pipe slope that you wanted to do for most optimization. And so then you can just hit apply and it will update your network. And then you can go through and spit out a report. Let's just move that back to 25, analyze, and then put out a report and save that on my desktop for now. That then you can utilize in Excel and print out and hand over to your project manager and have him review it. Or you could add this to your drainage report. If you're using an outside software, at this point now, when we click on our pipes, a lot of people ask me this, like, how do I actually get the HGL information without manually typing it in? Well, if you run it, it will automatically put that information in there. So on your pipe profiles, it will generate that HGL and EGL for you as well, based on your design standards. Once we go into our pipe network and we want to export out into there, we need to set up some migration defaults. And the first thing is the part list used in this drawing. And we're going to set that to be this one. And then our part matching defaults. We're going to go in and we're going to change this. And so this is if you import it in from storm and sanitary analysis or storm and sewer. And this is if you export out. So you can go through and then set these to the combination inlets, because storm and sanitary sewer analysis has different parts, and not all of the styles and part types that Civil 3D has in its parts list. So you kind of have to kind of double some up and then make some modifications and changes. And then after you go through, you can apply and save that. And we can go through and then we can edit this, and you can select which pipe run you want to analyze. And a lot of people ask, like, well, why do I have to draw from downstream to upstream? Well, this is one of the major ones. If you don't, when you go to export it out, I get denied. Right up there. When you go to export it out, the doesn't know where the outfall is, and you end up having to redo it in the storm analysis software, and it's much easier to do it in Civil 3D than it is to have to do it in the software program. So here's our outfall. So that's how it kind of follows that along. And that's about where we're going to have to end this one on our webinar, which is a shame because I really enjoyed talking with you guys today.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.